Good morning, CB. Good morning, Kartika. Good afternoon, Logita. Good afternoon, Dharni. It's not a hairdo, okay, CB. It's 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 emergency situation. Fine. Now, beta, can you send the link, beta, Logita, Dharini? Send the link in the group and tell everyone to join fast, beta. Send the link in the group and tell Nitesh, Shashri, Rajesh. Hello, how are you? Good afternoon, everyone. Good afternoon. It's not good afternoon. It's good evening, actually. Rashri. Yes, beta. First day of the school. It was a very tiring, hectic day. Come on. Chalo. Shall we start the class, beta? Good evening, Jenny. From tomorrow, you will also have the same situation. What I am facing today. Yes, Kamya. Good evening, beta. Good evening. Good evening, beta. How are you? How is my children? I missed you all so much today. Ayo. Good evening, Tawfiq. Good evening, beta. Good evening, Kamya. Yes, Kavya. Good evening. Okay, let's start the class, beta. What we have to exactly do is, Shri Bhavni, good evening. Shri Bhavni, whatever doubt was there, na beta, I saw it after class. I am going to clear it today. Okay, 100% I am going to check that doubt, beta. I'm fine, beta. I'm fine, Kamya. Now, shall we start the class, beta? Shall we start the class? Now, look here. Last class, we were talking about the law of reflection, and in that, we have understood that in law of refraction, the first law was that incident ray, refracted ray, and emergent all lie on the same plane. That was the first part. Good evening, Mativanan. And beta, all lie at the same plane. That was the first part we have studied about. Now, after that second part, we have exactly done Snail's law. That is 1621, he has invented this law. In that, he has exactly told that the angle of incidence and angle of refraction, that will be exactly helpful for finding the refractive index. And now we have also understood that refractive index is exactly responsible for finding how much the light is exactly bending. So bending capability of a light ray, how to know that by using refractive index, and with that beta we learned that how to find the refractive index of a material. Okay, that means a pair of media, refractive index of a pair of media, refractive index of a pair of media. Okay, Nandini, good evening. Kartika, good evening. Mustafa, good evening. Good evening, beta. V Kavya, good evening. Good evening, everyone. Good evening, S Kamya. Good evening, beta. Good evening, beta. Now look here, last class we studied this partner, sin I by sin R, that will be equal to constant. And then beta, next one more small thing we have discussed, and that was beta optical density relation with speed of light. And then beta, then we have studied relation with refractive index, and then we have studied relation with bending. So can anybody tell me, Abhinami, good evening, beta, if somebody will be asking you how bending is related to speed of light, then what relation you are going to say about bending related to speed of light? Just listen to my question nicely and everyone start typing the answer. But if somebody will be asking you how bending is related to speed of light, then what answer you are going to tell? What answer you are going to tell? Just type the answer and tell me the answer, beta. Today we will do some numericals also. Okay, today we will do some numericals. Absolute, Akshaya. That was the best answer. Inversely, auntie. That's it. That's it. If bending increases, the speed decreases. Very good, as Kavya. Inversely proportional, Bhavni, Rashri. Refraction, refractive index directly proportional. Bending, both inversely proportional to speed. Absolutely, beta. Inversely proportional. That's the best punch you have given to that entire section. What we have exactly understood that in that section. So now, beta, we will be doing one by one along with the speed of light and sin I by sin R. So we have understood one very important thing that time, last class, that sin I by sin R was exactly given by Snail's, and he has told that sin I by sin R equal to constant, sin I by sin R equal to constant, sin I by sin R exactly equal to constant, and this constant is nothing but refractive index. This is exactly called as refractive index. Okay, And then last class we have understood that okay, refractive index is denoted by n, and n is directly proportional to bending. So how much exactly be the bending beta, that means with that much high refractive index will be there. And then refractive index is directly proportional to optical density. If we will, if you might have exactly one small revision I am giving you beta, refractive index is directly proportional to optical density, refractive index is directly proportional to bending. So these two things we have understood. And then refractive index is inversely proportional to speed of light. That was what we have understood. Speed of what you called speed of or the velocity, speed of light, no, velocity. Okay, velocity of light, we will take velocity of light. Okay, so to be very precise, we have done, yes beta, offline class we will be exactly discussing about it one more time beta. Now listen, so this part already we have finished. Now we are going to go towards the next section beta. We are going to go towards the next section. In the next section beta, we are going to understand this part already we have finished. This section we have finished. Come on, check this one out. Just new PDF I am going to show you. So last class we have also studied about refractive index beta, and then we have also discussed some very good evening beta, good evening, okay. Fine. So I think my children are very excited for coming Saturday class. We will enjoy there beta. Now beta, we have exactly discussed about refractive index in the previous class. We discussed about the relation what we have done that time. Now we are going to understand some very typical things. Now I want my children to focus in this part of the class. Now here beta, please note that refractive index is ratio of similar quantities. So sines of, that is exactly the sine of angles, and because of that beta it has no unit. So refractive index, if somebody will be asking you what is the unit of refractive index, unlike force unit is Newton, you are saying that aunty force unit is Newton, and other physical quantities they have exactly unit, then what is the SI unit of refractive index? Then you will be saying that aunty refractive index is nothing but the ratio of sin I by sin r. Listen to me very nicely beta, refractive index is exactly the ratio of sin I by sin r, and because of that beta it is not having any unit, it is not having any unit, correct Janani, it is not having any unit, it is not having only numerical value, correct Sudarshan, it is not having any unit, it is not at all having any unit, that's why beta it is written that it does not have any unit. Now refractive index of a medium gives an indication of light bending ability. That is what we have discussed right now itself, that ki refractive index of a material tells that how much the light will bend on going from one medium to another medium. How much the light will bend on going from one medium to another medium. Means beta it is exactly reflecting that ki bending capacity will be how much. Means, and this will only be told by angle of incidence and angle of refraction. Angle of incidence and angle of refraction, they have the capability to tell the bending, how much bending will be done, and that bending is exactly nothing but directly proportional to refractive index. Now only we have seen. Now only that part we have exactly checked. Now the next important point is the refractive index of a glass is greater than the refractive index of water. Now can you justify the refractive index of glass is greater than the refractive index of water? This question I have asked in last class, and then what answer you have given that ki aunty refractive index of glass is more than refractive index of water. I still remember some of your answers, and that time you have explained that can Aunty, why? Because bending of light will be more in glass than that of water, because glass is optically denser. The speed of light in glass will become reduced and the speed of light in water will be exactly more. That means bending will be done more in glass than in water. Bending will be done. Very good, beta. So density of glass is greater than water. Tanishka, good evening, beta. Auntie, very sorry, no problem. I started late itself, beta. So bending is exactly more in glass than in water. Reason behind is refractive index is high because of high optical density of glass, because of speed of light in glass less. I hope this connection what I have generated few minutes back, that connection is going to explain the entire section of it. Now next important point we have to see that the light ray bend more on passing from air into glass than from air into water. Why, beta? Because of optical density. Because of optical density. In one word, I am just finishing it off. Now this numerical we have already solved in the previous class. Now we are exactly going to go towards refractive index and speed of light. Now can anybody tell me last class how we have denoted refractive index refractive index and speed of light? Can anybody tell me how to read out this one, beta? Last class we have done this part and I want any one of you to just explain this part, beta. That is, if somebody will be writing means 1 and 2. How to read it out, beta? How to read it out? Very good, very good. So Darshan, refractive index. Now beta, I am going to explain this one nicely so that there should be no confusion related to this part. So now look here, beta, how to read it out and how to write this one. It is written, beta, one medium to another medium, then speed of light in medium 1 by speed of light in medium 2. Now beta, exactly refractive index, when two different medium will be there, I am going to draw and explain this part, beta. Like one time understand, Tawfiq, everyone just listen this part, beta. Now you have two medium. Medium 1, okay, and this part is medium 2, beta. Now this is rarer medium and this is denser medium. When the light travel from rarer medium to denser medium, when the light travel, refractive index of medium 2 with respect to medium 1, absolute Tawfiq, any problem is there, beta? Refractive index of 1 with respect to, no. Kartika is correct, beta. Here Mustafa, power 1 power n multiplied with 2. No, never. Okay. Hello Yogi, how are you? And Janani, auntie, can you repeat? I am going to repeat this part, beta. I am going to repeat this section. Sudarshan, speed of light of medium 1 by speed of light. Okay, fine. Thank you so much. Now look here. Speed of light of medium 1 by speed of light of medium 2. Now come on, let's check this one out. How to do this section. Now come on. One small section we are going to do, and that part is exactly here. When you are writing this one, refractive index, then here refractive index, how you are going to read out the refractive index? The refractive index you are going to read it out as that refractive index of medium 2 with respect to medium 1. That's a bit I have written. When you are writing as 1 and 2, that means refractive index of medium 2. wherever we are writing, we are just giving preference to the second part. So refractive index of medium 2 with respect to medium 1. How to read it out? One quadrant and fourth quadrant. Mustafa, really you are in a very good mood, I think. Mustafa, seriously, come on, tell me. You are in a very good mood today. Refractive index of medium 2 with respect to medium 1. Come on, anyone can read it out like this one. Just air and water. Now, can you read this one out, beta? Here A and W is written and refractive index is written. Can you spell it out? How to read this one? Can you spell it? Oh, my voice box is crying today. Can you spell it out? How to read this one out? Read it out. Come on, tell me. How to do this one? It is exactly read out like that only, beta, because here now whenever you will be taking, then second medium decides the bending capability of with respect to the first medium. You know, Sudarshan, why we are discussing? Because refractive index talks about the bending of the light ray. Okay, Sudarshan. So what we are doing is, we are exactly denoting refractive index as the refractive index of medium 2 with respect to medium 1. That means what, beta? You have given that bending capability of medium 2 because of presence of medium 1. So that means when the light is exactly coming to medium 2 from medium 1. So that's why, beta, we always write it as refractive index of medium 2 with respect to medium 1. And let's see who has written this answer. First, exactly Kamya has written refractive index of water with respect to medium, that is refractive with respect to air, refractive index of water with respect to air. Absolutely correct, Logita. Refractive index of water with respect to air, absolutely correct. V.S. Kavya Janani, water with respect to air. Super. Sinchan, I agree with the guy, Muhammad. Hey, what happened, beta? Akash, so refractive index of water with respect to medium air. That is absolutely correct, beta. So whenever somebody will be writing, the reading part of it is coming as refractive index of medium 2 with respect to medium 1. So if somebody will be writing like this, then you will be saying that refractive index of water with respect to air. Refractive index of water with respect to air. And if somebody will be writing like this, then you will say that refractive index of glass with respect to air. Beta, because bending will be done in glass, bending will be done in water. So that means, and bending is exactly, the refractive index is explaining the bending capability. So that's why, beta, always we are writing it as refractive index of medium 2 with respect to medium 1. I hope my children might have understood this part. Where the bending is occurred. Correct, Sudarshan. Absolutely. So the medium where bending has been done, that medium first you are going to explain. Tawfiq understood that part, beta? Come on, quickly tell me. That means refractive index of medium 2 with respect to medium 1. Always we are writing that, beta. And then means writing part is going like that, but reading section is coming as speed of light in medium 1 by speed of light in medium 2. And this one will be written as V1 by V2. Okay. Speed of light in medium 1 by speed of light in medium 2. So beta, here now I am just removing this part because I think my children understood this section. Refractive index of medium 2 with respect to medium 1. So now the light will exactly try to enter from one medium to another medium. The moment it is trying to entering from one medium to another medium, it will bend towards the normal. It was supposed to go straight. Okay, means its plan was to go like this, but when it went from one medium to another medium, it got attracted towards the normal and it exactly bended towards the normal because of change in optical density. And exactly the bending has occurred. Change in optical density. Change in optical density, this bending has occurred, beta. So definitely, beta, only not angle of incidence and angle of refraction can give the refractive index, but another important thing can give the refractive index, and that important thing is speed of light, because speed of light is also changing from medium 1 to medium 2. So what and all things are changing? When the light is traveling from medium 1 to medium 2, if somebody will be asking you, then you will be saying that, hey, only one factor is not changing, here two factors are changing. First is angle of incidence and angle of refraction is changing. Second important thing is the speed of light in different medium will be different. So this speed of light also can give us refractive index, and angle of incidence and angle of refraction can also give us refractive index. Come on, tell me quickly first. Ayo, now beta, how it is? How it is? Tawfiq, is it okay beta? I'm going to explain, Tawfiq. I'm going to explain beta. I'm going to explain. I'm going to explain, Tawfiq. Don't worry at all, auntie is there. Now look here beta. Tawfiq, exactly what we were discussing na beta, ki when see, refractive index can be exactly done by two methods. One method is, Tanishka, just understand, everyone just understand this part beta, that refractive index can be found by two methods. One is n is equal to sin I by sin r beta. Another method of finding, because beta when the light will be traveling from one medium to another medium, this angle will be changing, and due to change in angle we will be able to find the refractive index, and refractive index wholesome is telling about the bending part. Okay, so now one thing is that change in refractive and change in angle of incidence and refraction can give us refractive index. Another important thing is on going from one medium to another medium beta, speed of light is changing. Like in air, the speed of light is 3 into 10 to the power 8 meter per second, but in water the speed of light will be 2.25 into 10 to the power 8 meter per second. That means on going from one medium to another medium beta, speed of light is also changing, and speed of light is changing, and angle of incidence and angle of refraction, that is changing, and they both are capable to give us refractive index. They both are capable to give us beta refractive index. Now understood na beta? Thank you Tawfiq, God bless you beta. So they both are going to give us what? Refractive index. I hope my children might have understood. Yes beta, N denotes refractive index. Now come on, quickly give me one charging battery. That auntie understood. Auntie understood. This section understood. Refractive index can be equal to sin I by sin r, auntie, and refractive index can be equal to speed of light in medium 1 by speed of light in medium 2. Speed of light in medium 1, correct Tawfiq. Thank you so much beta. Thank you so much. Speed of light in medium 1 by speed of light in medium 2. Speed of light in medium 1 by speed of light in medium 2. So if somebody will be writing this like this, you will be just saying, okay, hats off, super, great performance. Sin I by sin r, n will be equal to v1 by v2 also. That means beta speed of light in medium 1 by speed of light in medium 2. But beta here we are not writing medium, but here we are writing medium. Only one difference between this one and this one is कि when we are writing speed na beta, this was given by Snail's law. Now when we are writing speed, change of speed of light in two different mediums, at that time beta we are writing the medium also. This is the only difference here. So here we are writing the medium, and how we are reading it as refractive index of medium 2 with respect to medium 1. How we are reading it as refractive index of medium 2 with respect to medium 1 will be equal to speed of light in medium 1 by speed of light in medium 2. Speed of light in medium 1 by speed of light in medium 2. Yes beta, or directly, that is absolutely, optical density is directly proportional to bending. Correct only, absolutely correct Kardiga. So beta, tell me, these two formulas we have understood now. Now based on this we are going to solve some numericals beta. Understood na beta? Now one very important thing I am going to teach, and that is called as relative, okay, refractive index. What is the word I am using is relative refractive index. Relative refractive index. Then you will be saying, auntie, what does relative refractive index is? Very simple concept beta. Just understand that relative refractive index says that I hate air. I'm just joking. I'm not joking. Sorry. I'm not joking. I'm exactly telling that relative refractive index says beta. Relative, Kartika, what happened beta? Any doubt is there? Auntie, OD is correct only beta. Correct only. You are absolutely correct. You have told the correct point only. Now, most important thing is ki relative refractive index. What word I have used? Relative refractive index. What does relative refractive index means? Relative refractive index is that type of index index beta, in which we will take two mediums. Okay, two mediums we are taking, but that two mediums means air will not be there. Air will not be there means air will not be one of the medium. That means you can take refractive index of glass and water, refractive index of glass and water, but you will not be taking refractive index of air. That means it is called as relative refractive index. No problem beta. Yes beta, this part is very important. I am explaining each and every section of this part beta. So here one very important thing is relative refractive index. I will be teaching you fully beta, don't worry. Relative refractive index. What word is there beta? Can we discuss? Come on, type it fast, type it fast. What is relative refractive index? Relative refractive index is telling that change in speed of light from one medium to another medium, but that medium will not be air. Means every time we were taking this part na beta, every time we were telling that okay, here rarer medium is air and then denser medium is water. Now rarer medium is air, rarer medium is air and denser medium is glass. So now beta, every time we were taking like this, but now we are not going to take air. We will be taking two different mediums other than air. Then when two different mediums you are taking, yes beta, that is non-air, correct only. That in for understanding Akshay it is okay. That means we have taken two different mediums other than air, then that refractive index is called as relative refractive index. That is exactly called as what beta? Relative refractive index. What that word is called as? Relative refractive index. Come on, quickly tell me, this point you have understood what is relative refractive index. So if somebody will be giving you this one and will be asking that this is what type of refractive index, then you will say that here air is not there na, in both the medium air is not there, so it is called as relative refractive index. Relative refractive index. Come on Kamya, Vikavya, understood everyone? Come on, quickly tell me beta. Give auntie a charging part. That yes auntie, understood. This section I have understood that this part is exactly called as relative refractive index. Now beta, it is called as relative refractive index because we have taken two different type of medium other than air. So that's why beta, this part is exactly called as relative refractive index. Understood. Very good. Super beta. Super. God bless you all. So now look here. So we have understood now beta ki other than air, if any two medium will be there, then it will be called as relative refractive index. One simple example I am giving you beta. Inside water, one tumbler is there, in that water is there, in that water beta one glass or in that water one diamond is there. Hey, diamond I have kept. That means the light will go from water to diamond. So definitely beta, here it is exactly coming from water to diamond. So it is not going to be called as a refractive index where air is there. It will be exactly called as relative refractive index. Okay Mustafa, relative refractive index. Air is absent in this beta. That's why it is called as relative refractive index. What it is called as? Relative refractive index. Again and again I am repeating beta, relative refractive index. Now understand this part. So if the light is exactly traveling from water, so first medium is water and second medium is glass. That means medium one is water, second medium is glass, and then beta what will happen? The light will exactly come like this. Again it will bend towards the normal. The reason behind this, glass is optically denser than water. So since glass is optically denser than water, again bending will be done towards the normal. So here then you will be writing relative refractive index of glass with respect to air will be equal to speed of light in water by speed of light in air. That means speed of light in water, beta. Speed of light in water, we can write speed of light in water by speed of light in, by speed of light in water by speed of light in glass. Speed of light in water by speed of light in glass. So that part will be exactly called as what, beta? This one is exactly called as relative refractive index. Relative refractive index. Why it is called as relative refractive index? Because here we have taken two mediums. How many mediums we have taken? We have exactly taken, Auntie's kept diamond inside it. You know what auntie kept today? She kept diamond inside it. So definitely beta, very costly affair I have done today. So exactly refractive index of diamond with respect to water. That is called as relative refractive index. Correct only beta. Relative, wow, super Rashri. She has written RRI. That is relative refractive index. Wow, super yaar. You taught me new thing. Now look here. So beta, we have understood that if we are not at all going to discuss about air and we will be taking two different medium other than air, then it is called as relative refractive index. And after that beta, glass with respect to water. Absolutely correct Akshya, absolutely correct. Now beta, next thing is that another word is called as absolute refractive index. So we have understood relative refractive index na beta. Now we are going to understand absolute refractive index. Absolute refractive index. Now if somebody will be asking you what is absolute refractive index is there, then you will say that in relative refractive index you have exactly killed air na. You were taking two different medium other than air, but here what we are doing is we will be giving importance to air or vacuum. So always beta, it will be written as ki, okay, this part is exactly called as absolute refractive index. This is exactly called as absolute refractive index. So these two are exactly called as, diamond is a type of glass. Yes beta, diamond refractive index is highest beta. Diamond refractive index is exactly 2.42. It is having the maximum refractive index beta, maximum. It is exactly from air to diamond na. If light will enter na beta, it will have maximum. Tetrahedral structure is there and it will be having maximum refractive index. So if somebody will be comparing refractive index, then you will be saying that okay, why you are going very far? Diamond is having the maximum refractive index. Which material is having the diamond? Is the stone. Yes beta, diamond is a stone, but it is exactly when you will be taking, you take diamond as beta carbon. You say that diamond is one of the electropic form of carbon. And what is the difference between diamond and graphite is, one is having allotropic structure and their allotropes is there. But here one very big speciality of diamond is that it is having tetrahedral structure, and here beta no free electrons are there, and because of that what made it is a bad conductor of heat and electricity, and it is having, because of its hardness, it is exactly having highest refractive index. So beta, yes beta, it is made with coal only. So highest refractive index. So if somebody will be asking you which material is having the highest refractive index, then your answer will be, auntie, no doubt diamond is exactly having the highest refractive index. Okay, we will be having some questions related to it. Yes beta, here the bending will be maximum. Absolutely correct. Here in diamond na beta, when the light will be exactly coming from air to diamond, the bending will be exactly maximum. And you know, because of that bending only na, diamond is a sparkling. You know, it's tetrahedral. If original diamond you will see na, you will throw it. But beta, it's the tetrahedral cut is there na. From that, because of that, what happened, when light will exactly enter na, it will keep on bending. And because of it, it will keep on bending na beta, it will start having sparkling, because the light will be exactly entering inside and it will be exactly moving inside the medium, and because of that beta, that sparkling content will be there na, it will come. So I hope my children might have understood beta, might have understood that part. Diamond is optically denser and more bending, more refractive index and less speed. Super Rashri. Absolute, you nailed it, you killed it, you told the entire section of it, Rashri. Super. Tanishka, diamond, Sudarshan, and till have most bending and speed lowest. Correct only, Sudarshan. Absolute. Both three of you have given the perfect content of diamond beta. So that means we have understood another thing, that absolute refractive index means air to some other medium. When the light is traveling from air to some other medium, then it is called as absolute refractive index. In absolute refractive index, beta, sometimes we are not writing this also, we are only writing G. So it is self understood that the light is coming from vacuum or air and it is exactly entering into medium glass. Or sometimes when you will be seeing like this, then you will say that it is absolute refractive index. This is also absolute refractive index. The reason behind it is absolute refractive index, because the light has exactly directly came from air or vacuum to this medium. So only medium representation also if you will be doing, then it will exactly going to reflect what? Absolute refractive index. Now come on, can you identify the refractive index here? Which type of refractive index I am writing? Okay, come on, tell which type of refractive index if I am writing. I am writing here Al is exactly representing alcohol. Here Al is exactly representing alcohol. Then what is the exactly what type of refractive index is there? Because we have understood two different type of refractive index. Now you tell me, beta, it is which one? It is which one? It is which one? Think about it, beta. Here air is there and alcohol is there. Here air is there and alcohol is there. So if air and alcohol will be there, it will be exactly called as, yes, those who are exactly writing it as absolute, they are absolutely correct. Beta, because A stands for absolute, A stands for air. Okay, just remember like that. So absolute refractive index is going to take air. So air medium will be there. So here air medium is there. So this part will be called as absolute refractive index. Refractive index. So it is exactly what type of refractive index? Absolute refractive index. It is what type of refractive index, beta? It is exactly called as absolute refractive index. Absolute. Now beta, if somebody will be giving you this medium, K stands for kerosene and W stands for water. Okay, W stands for water. Now beta, K stands for kerosene and W stands for, absolutely correct, Sudarshan. Super Rashri. See, Rashri is going relative, absolutely, beta. Beta, now how to read this one? Refractive index of water with respect to kerosene. Refractive index of water with respect to, beta, kerosene. Refractive index of water with respect to kerosene. Why do we throw original diamond, auntie? The reason behind, beta, it's cut. If original diamond somebody will be giving you now, then it will not be like from from coal mines only. Many times you will be getting diamond because high pressure will be there. In absence of air, beta, this what you call the fossils will get converted into diamond. Okay, that is high pressure density has to be very high, air contact has to be reduced, means no air contact, then only, beta, that will get converted into diamond. So many of the times in coal mines you will be getting diamond, but beta, means that the diamond will not be that much sparkling. Its sparkle will come, beta, when you will exactly give it a three-dimensional cut, that is tetrahedral cut. The moment you will give it a tetrahedral cut, na beta, it will start sparkling. You know why? Because the moment light will enter from it, na, it will start showing bending capability, and the light, due to its maximum bending in the medium, it will keep on bending and exactly going, means once it will enter, it will exactly bend, and then it will come out. So what will happen? The light will be maximally inside and bending, so it will exactly makes the internal section more visible, and because of that, what will happen, beta, its sparkling nature will be coming, and that's why, beta, it is exactly called as that bending will be maximum in diamond, and that's why refractive index of diamond is highest, beta. Refractive index of diamond is highest. Yes, beta. I am going to teach Kartika. Relative does not have air as a medium, whereas absolute has air. Absolutely correct, beta. So if somebody will be telling you, just look here, beta. Kartika, just see this section, you will be able to answer it. I trust you. You will be 100%. You will itself give the answer. If somebody will be telling you, just identify which one is Which one is absolute refractive index? Which option is exactly showing absolute refractive index? Which option is exactly showing absolute refractive index? Which one is showing beta absolute refractive index? Come on, tell me. Among them, very good Janani. Very good Sri Bhavni. Kartika, absolutely correct beta. Sri Bhavni, absolutely correct. So which one is exactly showing beta absolute refractive index? Yes, Tanishka. That the correct answer is Mustafa, Logita, absolutely correct beta. Exactly the one, Dharani, that part is one is the answer beta, because here the light is moving from air to glass. So whenever the light, now Kartika, listen beta, whenever the light will come out from one medium and go to another medium, the first medium or the medium, one medium will be air. That means it will go for absolute refractive index. Means absolute refractive index means air has to be there. Absolute refractive index means what will be there beta? Absolute refractive index means air has to be there. I hope everybody might have understood beta. I hope everybody understood. In absolute refractive index what will be there? Air. In relative refractive index air is not there beta. Correct only, absolute correct Sudarshan. So from air, whatever medium it is writing, so air will be one of the medium, then it will be exactly called as, third one is relative. Yes, all these are beta relative, all the three are relative refractive index, only one is absolute refractive index, because in one only air is there. So that's why beta this is absolute refractive index and these are exactly called as relative refractive index. Relative refractive index. Relative refractive index and absolute refractive index. Okay, now beta one question I am exactly going to discuss here. I hope my children might have understood. So aunty, air will be medium 1 and medium 2 in absolute. Yes beta, the thing here is, here you can take that air as medium 1. You have to take air as medium 1 beta. Air has medium 1. So if the moment you will be taking air as medium 1 Logita, that time beta it will be called as absolute refractive index. Beta we exactly have taken rarer to denser medium. In denser to rarer medium if you will take, and that part also beta air will be mentioned as rarer medium, then to beta it will be coming as absolute refractive index. Why beta? Because in that air is one of the medium. So wherever one of the medium is air, it will be absolutely considered as absolute refractive index. It will be considered as beta air can't be medium. Okay, air can be medium. Absolutely correct Rashri. So here air is one of the medium. Correct only Sudarshan. One of the medium has to be air. So if one of the medium is air beta, it will be exactly considered as absolute refractive index. It will be considered as what? It will be considered as absolute refractive index. I hope my bacha party understood this part. It will be called as absolute refractive index. Absolute refractive index. Air is medium means absolute refractive index. Yes Kanishka, I know beta. Just 4 minutes please. I am with my class 10 students. Allow me beta. At least one numerical Kanishka. Just one numerical. Okay. Yes Nitesh understood na beta. Now we will be going. Just 1 minute beta. 1 minute. Now can you find the refractive index of when light is entering from air to water beta, what will be the refractive index? Come on, tell the answer beta. No, I am going to take their class. Pavam beta. I am going to take their class. Solve it beta. Absolute refractive index. But how much refractive index will come? You have to solve and tell the answer beta. What will be the refractive index? How much refractive index will come beta? How much refractive index will come? How much refractive index will come? Can you calculate and find beta? Yes beta. That's why I was asking time. You don't know. Sudarshan. Come on. Tell me the answer, beta. Beta, here nothing you have to do, beta. Look here, Janani, the light entered from air to water. That means, beta, when light is entering from air to water, that means light is exactly coming from air, beta, and it is going inside water. So what is the speed of light in air? You will say, auntie, you know, speed of light in air is 3 into 10 to the power 8 meter per second. Then I will ask you that, Jenny, what is the speed of light in water? Then Jenny will say that, auntie, you know, speed of light in water will be exactly 2.25 into 10 to the power 8 meter per second. So now we will be telling that what is the refractive index here. So you will say that, you know what, anti-refractive index will come from air to water, and it will come speed of light in air by speed of light in water. Now you have to just write the formula, beta. Now how to read as speed of light, refractive index of water with respect to air will be equal to speed of light in air. So you will be saying, auntie, this part will become 3 into 10 to the power 8 by 2.25 into 10 to the power 8. So this 10 and this will get cancelled, beta. So 3.00 is there and 2.25 is there. So just what we will do here, 3 is there, this will get cut and 100 will go up. So 300 by 225 is there, beta. So once 300 by 225 is there, 1 point something refractive index will come. 1 point something refractive index will come. If you will solve this question, then here it will come 5 4s are 20, 5 5s are 25, then 5 6 are 30, 0, then 3 2s are 20, and there 3 1s are 3, 3 5s are 15, then 5 4s are 20, 5 3s are 15. That is, beta, 3 dividing 4 is, so here 1, so 0.0, so 1.33. So here refractive index will be 1.33, and beta, it is always fixed. It is fixed. It is fixed means कि refractive index of glass, if somebody will be asking you, then you will say that refractive index of glass is 1.33. Then they will be asking you that with respect to what you have taken the refractive index of glass, then you will say that when the light is traveling from, listen to me nicely, when the light is traveling from air into glass, the refractive index at that moment will be 1.33. When the light is light is entering from, correct only, beta, I took water na, the refractive index of, I hope you might have understood this part. Come on, quickly tell me, beta, 1.33. Hey Akash, understood or not, beta? Rashri, you have doubt, beta. Now let me 1 minute. Rashri doubt. Anti-refractive index of air with respect to glass. This is also absolute. Yes, beta. This is also absolute. Any one of the medium, beta, it has to be air, Rashri. Then it will be called as absolute refractive index. Rarer or denser, any one of the medium. If it is exactly down, understood. Okay, beta, that means refractive index of one medium with respect to other. So here, beta, if this is fixed, if water if water we are taking, then refractive index of water will be 1.33. It will be exactly fixed, beta, refractive index. Beta, speed is slow in water because of a very important reason. Tawfiq, you know this part, beta, that when light is entering from one medium to another medium, due to optical density, the wave will be exactly, we have discussed already that Tawfiq, that the one wave which will be entered inside it, it will enter first and then slow down, then another wave will enter, then another wave will slow down. In this way, beta, when the light is coming from a rarer medium to denser medium, Tawfiq, then beta, it will keep on bending towards the normal, and that is what, beta, that's why the speed will be reduced because of this bending, because of the wave entering one by one, beta, its speed will be reduced. Okay, that is optical density will be more. Absolutely correct, beta. So here optical density is going to be more, and because of that also it will be exactly going to bend. Tawfiq, understood that part, beta? Tawfiq, come on, quickly tell me, Tawfiq, understood na, beta? Tawfiq, come on, quickly tell me, beta, did you understood that part? Okay, so whenever topic anybody will be asking you now कि why speed is exactly slowing down on going from one medium to another, then you will say, you know what, air density, optical density and water optical density is different. So that's why when light is entering from air to water, the density is exactly changing, and because of that the speed is reducing. Because of that the speed is exactly reducing. Hi Darshini, I'm going to start your batch. Darshini, just give me 1 minute. Okay, fine. I'm going to keep it till here, beta. One question only we were able to solve. Tomorrow we are going to solve more questions, and we are going to finish this refractive index. Then we will start lens. We will start lens, beta. Okay.